Hello dear students. In the previous video, we had studied about fluid statics. In that, we had studied about Pascal's law, buoyancy, Archimedes principle, and law of flotation. Here, in this video, we are going to study about the fluid dynamics. So this is our first class on fluid dynamics. So what do we mean by fluid dynamics? In fluid dynamics, we'll study about the flow of liquid or flow of fluids. So what is fluid dynamics? It is basically the study of fluid flow. Means initially Archimedes principle, buoyancy, Pascal's law, all these were related with the fluid at rest. But today we are going to study about the fluid flow. As we all know that fluid is made up of molecules, right? So here we'll have certain layers on which the other layer of the fluid moves, right? So to find the there is a frictional force which is responsible for the motion of one body over the other. In the same way, one layer of the fluid moves on the other layer with the help of frictional force, and that frictional force is called viscosity. So what is viscosity? Viscosity is basically the property of the fluid, that is liquid or gas are called as fluids, by virtue of which an internal frictional force comes into play when the fluid is in motion in the form of layers having relative motion. It opposes the relative motion of the different layer. Viscosity is also called as fluid friction, right? So here, if we assume that this first layer is moving over the second layer, so here there will be a separation between the two layers, and that separation is defined by dx. And the fluid which is at the topmost layer will have the maximum velocity, that is v. The layer which is below the top layer will have the velocity lesser than the velocity of the top layer, and that velocity can be written as v minus dv. Second layer, third layer की जो velocity होगी, that will be smaller than the velocity of the second layer, that will be v minus, suppose here also we'll have a separation of dx, then it will be 2 v minus v dv, 2 times of v dv. And this velocity keeps on decreasing, and the layer which is at the bottom of the surface of the earth will have the velocity will have the minimum velocity. So here is a law which is called as Newton's law of viscosity, and this law says Newton's law of viscosity, and this law says that viscous force between the two layers of the fluid is directly proportional to the area of cross section of the two layers which are in the contact with each other, and it is also directly proportional to the velocity gradient, that is dv by dx, that is the difference between the velocity of the first layer and the second layer, which can be written as dv, and the separation between the two layer is dx. If we'll combine both these equation, then we'll get f is directly proportional to a dv by dx. So this f will be equal to a constant, and that constant is represented by eta, and this eta is called as the coefficient of viscosity. It is same as we write the frictional force as mu into n, and this mu is called as coefficient of friction. coefficient of friction. So here we got the formula to find the viscous force. This is basically the formula to find the viscous force between the two layers two layers moving two moving layers two moving layers of the fluid. So to find the viscous force between the two layers of the fluid is given by Newton, and it is F is equal to neta A dV by dx. Now we have a second law which is called as Poissons law. According to this law, if we have a capillary tube, what do we mean by a capillary tube? A tube which is having a very small diameter. That means if any tube is having a very small diameter, obviously it will have a very small radius. So if the length of this tube is L and diameter is D, that means we can write uh, radius as R over here. So according to Poiseuille, if the pressure difference, suppose the fluid is flowing from right to left, right to left, that means there will be a pressure difference from right side of the pipe to the left side of the pipe, and that pressure difference is given by P. So the volume of the fluid coming out of the tube per second, and this is called as the rate of flow of fluid. So we can write it as V by T is equal to pi by 8. The pressure difference, suppose this is P1 and this is P2, so pressure difference can be written as P1 minus P2. From the first end to the last end, the pressure is P1 minus P2. There will be a pressure difference, that P1 will be the higher pressure and P2 will be the lower pressure, and it can be written as P r to the power 4 upon neta L, where neta is the coefficient of viscosity viscosity of the fluid. So the volume of the liquid coming out of the tube per second, that is the rate of flow of the fluid, is directly proportional to the pressure difference. It is directly proportional to the fourth power of the radius of the capillary tube. It is inversely proportional to the coefficient of viscosity, as you can see directly in the formula, and it is also inversely proportional to the length L of the capillary tube, and it is given by V by T pi by 8 p r to the power 4 upon neta L. Here this formula is written as it is per second, so the second time will be 1 second, so it is written as volume over here, and it will be pi by 8 p r to the power 4 upon neta L. Capillary tube is basically, we can find it in the plants, from where if we, अगर हम पानी देते हैं प्लांट को, या जो भी मिनरल्स या जो भी चीज़ें हम प्रोवाइड करते हैं प्लांट की ग्रोथ के लिए, वो सारी की सारी चीज़ें कैपिलरी ट्यूब के थ्रू क्या कर रही होती हैं, उस लीव्स तक पहुंच रही होती हैं. उस तरीके की ट्यूब्स हैं यहाँ पे. So that tube will be having a very, 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 very small radius, and the rate of flow through those kind of tubes is given by V by T PR to the pi by 8 PR to the power 4 upon neta L. So this is our second law, that is called Poissons law or Poissons equation. Next is we are having a Stokes law. According to Stokes' law, the backward dragging force acting on a small spherical body of radius r moving with velocity v through a viscous medium of coefficient of viscosity neta is given by 6 pi neta r v, where v is the velocity with which the spherical body is moving in the fluid. So here what we take is, we take a fluid which is having infinite depth and a spherical body. This formula is basically applicable for spherical body. I have assumed a spherical body over here which is having a radius r, which is having a r and radius r, radius r, and the density of the fluid is sigma, rho, and the density of this body which we had assumed as spherical is sigma. If this body moves around a fluid having infinite depth, will attain a velocity v while moving through this fluid, and this velocity will be a constant velocity. This will be a constant velocity. So it will also experience a viscous force, that is the frictional force due to a fluid, and that frictional force is given by 6 pi neta r v, where neta is the coefficient of viscosity of the fluid, r is the radius of the spherical body, and v is the constant velocity by which that spherical body is moving. And this is called the viscous force experienced by a spherical body while moving through a viscous fluid. So here this v is basically called as terminal velocity, and this terminal velocity is defined as the maximum constant velocity acquired by a body while falling freely in a viscous medium, and this is attained when the apparent weight is compensated by the viscous force, and it is given by v is equal to 2r to the 2r square rho minus sigma g upon 9 neta. How to identify this expression? Let's see. As we know that it is a maximum constant velocity, that means the motion is uniform motion. So if I am having a fluid, viscous fluid, and in this viscous fluid a spherical body is moving, this is a spherical body having density sigma, and the density of the fluid is rho. It is also having a radius r. So it will experience a viscous force, that is Fv, and it will also experience a buoyant force due to a fluid. And in the downward direction, I'll be having mg. So as the motion of the spherical body is uniform motion, uniform motion, upward force must be equal to downward force. So upward force is Fv plus downward force is Fp, and this will be equal to mg. So the mass of the body can be written as sigma v into g. So this will be the weight of the body in terms of its density, right? So viscous force is given by 6 pi neta r v t. This is the terminal velocity. And the buoyant force is given by rho vg, and it is given by sigma vg. So 6 pi neta RVT is equal to sigma minus rho into V into G. This Vt is equal to sigma minus rho. Instead of V, I can write 4 by 3 pi r cube as the volume of the spherical body into G divided by 6 pi neta into R. If this R is cancelled out with this, it will be square. Pi will be cancelled out with pi, and this will be 2 and this will be 3. So Vt can be written as 2 by 9 sigma minus rho r square g upon neta. So this will be the expression of terminal velocity. As by seeing the expression of terminal velocity, we can say that this terminal velocity is directly proportional to the difference between the density of the fluid and the body. It is also directly proportional to the square of the radius of the spherical body and inversely proportional to the viscosity of the fluid in which the body is moving. This terminal velocity is independent of the height. Terminal velocity, that is Vt, is independent of the height from where the body is dropped in the fluid. इसका मतलब क्या हुआ कि अगर आप इसको बिल्कुल फ्लूइड के सरफेस से भी अगर आप इसको ड्रॉप करा रहे हो तब भी टर्मिनल वेलोसिटी कितनी अटेन होगी. अगर आप इसको 1 किलोमीटर ऊपर से ड्रॉप करा रहे हो, इन दैट केस ऑल्सो यू विल हैव द सेम टर्मिनल वेलोसिटी. Terminal velocity can be positive as well as negative. If sigma is greater than, where sigma is the density of the body, is greater than rho, then terminal velocity Vt is in the downward direction, and if sigma is less than rho, Vt will be in upward direction. ऑब्वियस सी बात है, एक नेगेटिव साइन आपको देखने को मिलेगा. अगर Vt पॉजिटिव है मतलब डाउनवर्ड डायरेक्शन में अगर जाएगा तो वो पॉजिटिव होगा, और अगर अपवर्ड डायरेक्शन में जाएगा तो वो नेगेटिव आपको देखने को मिलेगा. तो इट कैन बी पॉजिटिव एज वेल एज नेगेटिव. सो आई होप you people have understood the Newton's law of viscosity, you people have understood the Poisson's formula and the Stokes law, and also the concept of terminal velocity and how to get the expression for terminal velocity in this video. That's all for today. Thank you so much and God bless you all.